Hey class, today we're going to be doing 8.1, which is geometric mean. Our objectives today are to find the geometric mean between two numbers, and then to solve problems involving relationships between parts of a right triangle and the altitude of its hypotenuse. Just think about the word relationships. We have seen a lot of relationships that involve ratios, and ratios involve proportions. So keep those in mind, which is going to bring us here to our first one. A proportion is used when comparing two ratios, two equal ratios. And looking here at this problem setup, we're going to label a few of these things. We're going to call this an extreme, and x is a mean. So the other x is going to also be a mean, and b is also going to be an extreme. When we say mean, that mean is going to represent our altitude. All right, so typically when we solve proportions, we cross multiply. So we would get a times b, and here we'd get x squared. If we wanted x by itself, we have to do the opposite of squaring, which is square rooting. So x equals the square root of a times b. An example of what we would be thinking about is if we had 1 over x and x over 4, we're looking for the same number to fill in for x that would make this proportion an equal statement. So if we plugged in 2 for both of those x's, we have 2 over 4 and 1/2. 2 over 4 is going to reduce to that 1/2. So when the means of a proportion are the same number, that number is called the geometric mean of the extremes. All right, so let's go ahead and use this. The big thing you need to remember is right here. Find the geometric mean between 8 and 10. So before, we're not even going to put it into that proportion. We're just going to go right into the square root of 8 times 10. All right, 8 times 10 gives us 80. And now we take the square root of that, so we get 8.9. All right, so looking at the second problem, let's get it set up. We have x equals the square root of 9 times 4. And go ahead and take 9 times 4. We get 36. And the square root of 36 equals 6. So finding the geometric mean between two numbers is pretty basic. This isn't in your note sheets, but this is just a little reminder for us about what an altitude is. The altitude is a segment drawn from the vertex of a triangle perpendicular to the line opposite. And remember back at that objective, if we go back just a couple slides, it says the altitude of its hypotenuse. So in our triangle, we have our hypotenuse, which is the longest side, and our altitude is going to be from the vertex, and it's perpendicular. And what that does is that breaks it down into multiple triangles for us. And we are going to see that here. If the altitude is drawn to the hypotenuse of a right triangle, then two triangles formed are similar to the original and to each other. Remember, the word similar is going to mean that their angles are congruent and sides are proportional. All right, so if, we're going to drop down a CD. So if segment CD, so that means we're dropping this down and making a right angle and putting in a point D, is the altitude to the hypotenuse, then triangle ACB, that's this large one here, is congruent to, now we're going to look at our small one, ADC. So those two triangles are similar. All right, let's clear that out of the way. And triangle ACB again is congruent to, and now this time we're going to choose our medium-sized triangle, CDB. Now if we compared those letters in these triangles, the A's, A and C, are going to be in the same position from those triangles. And lastly, if we get rid of the red one, and we compare the blue one and the green one, So our blue one, ADC, is going to be similar to our medium-sized triangle, CDB. So those three triangles are all going to be proportional to each other. All right, so if those are all proportional, and we drop down that hypotenuse, or that altitude again, and we're going to call it D, and if we looked at some of those triangles, we could say, oh, and you know what, let's call that H. All right, so if we compare my two smaller triangles, what was the green and the blue before, we're going to call this X. I should do that in black so you can see it better. X, and then this triangle, which is our medium-sized one, and we're going to call this Y. So we're comparing those two triangles. If we compare X and H, so X is my short leg, and my long leg is H. Now I'm going to look at my medium-sized triangle, and I'm going to find my short leg. So in my medium-sized triangle, my short leg is this one here, H, to my long leg, which is my Y. So notice we have our short legs on top and our long legs on bottom. So they came from the two different, and the nice thing is that we have that H and H. So if we did that, work it through, we're going to get the same idea as we saw at the beginning. So proportion, short leg to long leg. We also can see this next one, which is on the back side. And we're actually going to draw the altitude again. Call it H. We have X and Y again. All right. So we're going to be looking this time at our small and our big one. So here's our small one. All right. Now we're going to take the hypotenuse, B. So B is my hypotenuse. And we're going to compare it to, oh, you know what? Yep, that'll work. B and then our X, which is our short leg. Those came from our small triangle. And now we're going to compare it to our large triangle. So again, we're going to do our hypotenuse. And that's C, that's that whole long piece. And then our short leg, which is our X. Oh, and not our X, our B, excuse me. So again, we have our hypotenuse on top and our short leg on bottom. We can also do that with our small triangle and our medium-sized triangle and our large triangle. In our medium-sized triangle, if we do our hypotenuse, which in our medium-sized triangle is A, and we're going to go with our long leg this time, which is Y. We can do the same thing with our large triangle. The hypotenuse is C, and the long leg in this one is A. Again, notice here that we are going to have our variables that are going to be diagonal of each other, and that's important. So let's put this part to use. Really, just having those figures doesn't do a lot for us with these problems. But now we can take that and apply it here. So let's draw out these three triangles to help us find X, Y, and Z. So we have our large one, a medium-sized one, and a small one. In our large triangle, let's always start off with finding our hypotenuse. And so across from our 90-degree angle is that. And remember, this is going to be this whole side. So it's 25. And in relationship to that, our short leg is Y and our long leg is Z. All right, now if we're looking at our medium-sized triangle, so that's going to be this one now. Okay, found our 90-degree angle. Across from it is Z. Our short leg is going to be X, and our long leg is going to be 20. Now notice between these two triangles, no variable or number is in the same spot. So our short legs are different, our hypotenuses are different, and our long legs are different. All right, so now let's take a look at our small triangle. If this is a 90-degree angle here, we know this one is too. So directly across from it, that's our Y, is our hypotenuse. Our short leg is 5, and our long leg is X. All right, so we're going to use those proportions we just talked about, short to long, hypotenuse to short, and hypotenuse to long. We can use any one of those to help us out. Now here's the trick to these next three problems. you can do one proportion and two Pythagorean theorems. That's going to make it easy for you. If you choose to, you can do three proportions. You can do two proportions. But I find that it's easiest for students to do one proportion and two Pythagorean theorems. So first thing, let's just say I'm going to look here. I have my hypotenuse and my short leg, hypotenuse and short leg. And now I'm going to look at my next two triangles and see if hypotenuse, short leg is going to match up. If we look here, we have x and z. Well, we don't want to intermix our variables. We've already chose y. So that's not going to work for us. So let's get rid of that green circle and put that over there. And then let's look here at this last one, hypotenuse and short. I see a y, my hypotenuse is y, and my short is 5. Great, I have one variable to deal with. So we're going to go ahead and do our cross multiplication. So we end up with y squared, and then take 5 times 25, or 125. Take the square root on both sides. All right, so you guys square rooted both sides, and we end up with 11.18, blah, blah, blah. And we're just going to round that to one decimal place. So we have 11.2. Now that we have our y, we can actually go through and clear out. Let's clear out some of these circles. And let's get rid of the y. And we're going to change that to our 11.2 now. Now looking at our large triangle and our small triangle, we see that we have two sides and we have one variable. So set up Pythagorean theorems for both of those and go ahead and finish them. And now yours might be off by just a decimal place or two. It depends on what proportion you choose. Let's look at another one. Here we go with this one. I'm going to move this out of the way a little bit. Let's start off with the same thought process of drawing out three triangles. Our large one, our medium one, and our small one. Let's make our small one look a little bit more proportional. Short leg, long leg, hypotenuse. All right, so looking at the large triangle, here's going to be our right angle. And look over there. Ooh, this one looks a little bit different. Last time we could add the 2. Here we're going to add the 2, but we end up with x plus 9. Our short leg is z, and our long leg is y. All right, if we're going to look at our medium-sized triangle, we have our hypotenuse, which is right across from that right angle. So our hypotenuse is y. Here we go, our short leg is going to be 12, and our long leg is going to be x. The thing, if you're not sure about that sides, is watch where you put your other stuff and make sure that you're not putting numbers in the same spot. And our small triangle, 90-degree angle, so that means our z is our hypotenuse. Our short leg ends up being 9, and 12 is our long leg. Now I'm going to go through and help you guys find some proportions that we can use to set up. So if we look and we have our x and 12 here, we want to see here we don't have another variable, but we see that number 12 up here again. That is our geometric mean. So we can set that up, short leg to long leg, and short leg to long leg, and cross multiply. And you're going to be able to find x that way. So we get 9x equals 144. So x is 16. Now we did one proportion. We're going to go ahead and do two Pythagorean theorems. But if you want to see some other proportions, we want to look for and see why we would do Pythagorean theorem, why it makes it a little bit easier. If we look here, we have 9 and z, and we look at our other two triangles. We don't have in our medium triangle here, we don't have a z in this part right here. So that's not going to work to set up as a proportion. Oh, not what I wanted to do right there. All right. If we look at our large triangle, we have a z and an x, which we found was 16. So we would replace 16 in for x. And there you could do another proportion. And then if we look here again at our medium triangle, we can't do our hypotenuse and our long leg, but if we move over here, we have hypotenuse and short leg, hypotenuse and long leg. If we try here, we see we have Y, and here we have Z. So that's why we wouldn't want to do that. That's why it makes more sense and is easier to do with proportion and two Pythagorean theorems. So we have this last one here, and I'm just going to get it set up for you. I know the video is getting a little long here. And notice we have missing sides. We only have 3 sides. If we draw out our medium and our small triangle and look at those, so short leg, long leg, hypotenuse, short leg was 6, W plus 4. And on our medium-sized triangle, W plus 4 was our short leg, and our long leg was 24. We're going to be able to set up a proportion right here. So if we do short leg over long leg and short leg over long leg, now you've got a proportion. We're going to cross multiply here. Don't forget that would involve a FOIL. All right. Thank you guys for watching 8.1 Geometric Mean. Have a good day, guys.